So today we are adding synthetic division. Synthetic means we've like formed it from pieces. It's like a put together. It's not organic. Organic being like alive. Synthetic being like more man-made. So the division is going to do the same thing that polynomial division does. We have some caveats. This really only works, so it does work for, well, really only works if dividing by x minus k. So, for example, x minus 4, x plus 2. Not x squared minus x plus 2, which we did talk about how to divide, or like 3x squared minus 5. Okay. Now here's the thing. It will work for stuff like, I'm going to write this on another piece of paper because I'm not going to put it in my notes. It will work for stuff like 3x minus 2. This is just an x. But you would need to convert this to x minus or x minus 2/3. You don't need to write this in your notes. And then you're going to use a fraction. So don't use synthetic division for this kind of problem. Just use the normal division. Okay, so this is the kind of thing we're looking for. X minus or x plus some number. It would work for that other thing, like 3x minus 4. Yeah, so we're talking about the stuff for the homework that I sent yesterday. Yeah. Okay, this is a shortcut for polynomial long division. It also does some other stuff. We're going to use it to evaluate as well, but I'll talk about that after we talk about how it actually works. So I want to start with polynomial long division, just problem. You're like, well, but we already did that. Well, yeah, I want to show you where the synthetic division comes from. So we're going to divide negative x cubed plus 4x squared plus 9 by x minus 3. And let me know if I'm moving up too fast and you wanted to write that stuff. So this is not synthetic division yet. We're just going to do long division. Negative x cubed. This is a 9. Yeah, 9. X cubed plus 4x squared plus 0x plus 9. So remember, we need to include the terms we're skipping. So this goes x cubed, x squared. There's no x and then a 9, so we have to include the 0x. There's no x's, that's why it's 0. Now I want you to really think about the processes that we're going to take through this division problem. They're going to be the same processes we do with synthetic division. We're just going to write it in a different way. So the first thing we do is we divide this number. So in synthetic division, we're not going to do that part, but it's going to be negative x squared. And then we're going to multiply both of these by this number, right? So we get negative x cubed, and then we multiply the negative 3 by the negative 1 that's in front of the x squared, and we write it here. So that would be plus 3x squared. And then we subtract. And so we get 0, and then we get just an x squared plus 0x plus 9. Okay, we subtracted here, and then we added these things down. We just brought them down. Okay, so we're going to multiply again, or we're going to divide. So we get an x, and then we multiply this x times this 1x times both of these numbers. So x squared minus 3x. And then we're going to subtract. And so we get 3x plus a 9, which means this is a 3. 3x minus 9. When we subtract all of this, we get plus 9, so we get 18 here. And so our remainder plus 18 over x minus 3. So what are we doing over and over? We're multiplying, right? So we're finding this number, and then we're multiplying both of these things, and then we're subtracting. So we're multiplying, and then we're subtracting. Over and over and over. Make sure I got the right answer. Yep, that looks right. Okay. Multiplying over and over and over. What if we switched it so it wasn't subtracting? This is normal division, Brian. We haven't introduced the synthetic division yet. We just did a normal division problem. I'm going to do this same division problem with synthetic division in a second. So yeah, it's the same so far. I just wanted you to see what we're doing. We're going to multiply here. Oh yeah, no, not yet. So we multiplied, and then we subtracted down, and then we multiplied. And notice this -3 is showing up over and over. It shows up here, shows up here, and it shows up here again. Right? We're multiplying this by this number. We want to swap this subtraction, and we want to make that addition, because addition's easier. So that's part of synthetic division, is we're going to make stuff easier by switching this to addition. The other thing that we want to do is like clean up this notation and squish it. If you really look at what we're doing, well, I'm adding these numbers and multiplying by this, and I'm adding these numbers down, and I'm subtracting, sorry, I'm subtracting these numbers, I'm subtracting these numbers, and I'm subtracting these numbers. So let's rewrite a bunch of stuff. This is now going to be the synthetic division. Step 1. And I'm going to list out my steps as I go. Step 1, list the coefficients. We'll color code our steps. So we're going to make a little L-shaped box to keep track of our numbers. And we're going to list the coefficients. So we're doing the same problem. So I'm going to use -1, 4, 0, and 9. We need to include the 0. Including zeros. So it was -1, 4, 0, and 9. I'm just going to list those out. I'm going to need more colors, but that's fine. Step 2. Use the opposite number of k. So k being x minus k, the thing we're dividing by. That's going to go right here. So the problem was dividing by x minus 3. So I'm going to write a +3. Remember, we're switching from subtraction to addition. And so by switching the value there to the opposite sign, that's going to switch us from subtraction to addition. So now we can just add instead. Now that 3 is going to come up. We're going to use that 3 over and over and over. Just like the normal division, we used that 3 over and over and over because we multiplied by it. Okay, step 3. Bring the first term down. We get -1. You'll notice in our answer to the first problem had -1 in it. Right, so our answer up here in blue, we started with a -1 and we had a -1. So we bring this -1 straight down. Excuse me. Now we're going to multiply that number by 3 and write it in the next line. So multiply the first term by k and write it on the next line. We're going to write it here. So we're going to multiply 3 times -1 and we're going to get -3. We're going this way. Write it in the next column. Then we add down. So now we just add, step 4 is add, or step 5, sorry, add down. So 4 plus -3 gives us 1. Now, you've already seen that step happen up in the previous problem. We multiplied everything here by -x squared, and then we subtracted the 4 and the 3. Because we switched the sign of this 3 to a positive, we now don't need to we don't need to subtract. We're just going to add because we switched the sign. We already did the subtraction by switching this to 3, and so now we can just do addition. So we're going to add down, and then we get 1. And then we just repeat that process over and over and over. So the next step is repeat until the remainder should only be 1L. So now we're just going to repeat. We're going to multiply diagonally. This is a really verbose way to say we're going to multiply diagonally and add vertically. And every time we're going to multiply by 3. So 1 times 3 gives us 3. Multiplied like this. And then we're going to add down. So 0 plus 3 gives us 3. 3 times 3 gives us 9. We multiplied there. And then we add down and we get 18. Now this is just a bunch of numbers. And so we need to rewrite this as our answer. So step 7, I'm running out of colors. Step 7 is use the new coefficients, these numbers, use the bottom numbers, as coefficients for the answer. So remember, we're dividing by an x. We're dividing by x minus 3. So we started with x cubed, and now we're going to write our answer in terms of x squared. We reduced the exponent by 1, so it's going to be minus x squared plus an x plus a 3 plus 18 over the thing we were dividing by, x minus 3. We were dividing, that fits really perfectly, but we were dividing negative x cubed plus 4x squared plus 0x plus 9. We're dividing all of that by x minus a 3. And so because we're dividing the x's by x, the exponents are going to reduce by 1. So it goes from 3 to 2, from 2 to 1, and from 0 to just the number. Or from 1x to the number. Any questions so far? Okay, the key is going to be adding vertically and multiplying diagonally. We're adding down and we're multiplying by this 3 every time diagonally. How do you know the order of the coefficients? So the order of the coefficients is the standard form order. The problem needs to be in standard form, and you need to include the zeros, right? And so this was x cubed, negative 1x cubed, so that's the first one. And then it goes to x squared, so then it's 4, and then x, and then the constant. So the order of the numbers go in standard form. Same for our answer. If you get a 0 here, like if this was 0, you wouldn't have an x, it'd just be 0. Does that answer your question, Brian? How do you know the order of the coefficients? We're going to do some more of these. And then we have a theorem. Yeah, there's time. You couldn't hear any of it. So the way we know the order, like why is it negative 1, 4, 0, 9, and not these numbers in a different order, is because it's in standard form. Use the standard form order. So biggest exponent to smallest exponent needs to be in that order for synthetic division. Okay, let's do another one. Do another example. Maybe 2 more. We'll see. So I gotta flip my paper over because I'm out of space. Okay, so we're going to divide 3x cubed minus 2x squared plus 2x minus 5 by x minus 1. X plus 1, sorry. So I'm not going to color code all of this problem. Mostly because the colors are just made up. I just wrote the steps out. So we're going to make our L-shaped thing to keep track of where the numbers are. And then our coefficients go here. So it's x cubed, x squared, x, no x. So we go 3, negative 2, 2, negative 5. And then the number that we're going to be multiplying by each time is the opposite of this number, the opposite of plus 1. Whatever turns this into 0. So we use -1. Okay. And then we're going to add down. And then we're going to multiply diagonally. So my first step is just add down. So this is the first number, 3. Just bring that one down. Don't need to draw the arrows, but we can. Let me switch colors while we're working the problem out. So 3. We're going to multiply 3 times this number. And we're going to multiply this way. So -1 times 3 would be -3. And then we add down. So we get -5. And then we multiply -5 times 1. We get 5. Add down, we get 7. Multiply by -1, we get -7. Add down and we get -12. So I'm multiplying this way. Because it's -1, the sign's just changing every time. And I'm adding down. You don't need to draw all the arrows. Okay, they're just to help you keep track of what I'm doing as I go. So I'm multiplying, adding down, so 3 became 3. We're adding to 0 the first time. Then we multiply by -1. Add down, we get -5. Multiply by -1. Add down, we get 7. Multiply by -1. Add down, we get -12. So then our answer is going to be these coefficients, except the exponents are going to be reduced by 1. So 3x squared minus 5x plus 7, and then this is our remainder. We kind of want this to be 0, but we don't have any control over what number it is. So it's going to be minus 12 over, we were dividing by x plus 1. Good, Everett. Yeah, no, it makes it a lot faster. There's a lot less to write, but it does the same thing. I mean, we could do long division on this problem. You could. You'd get this thing in purple if you did long division. But we're not doing subtraction anymore, so we don't have to keep track of as many negatives, which is good. That should be really helpful. And we're not writing x every time or the variable every time, so that should save us a lot of time too. Okay. Other than that, we're basically writing all the same numbers. Let's do one more, except I'm not going to write any of the arrows. I'm going to write it in the way that I would normally write this kind of problem. Okay, so we're going to divide. I'll do it. Divide 2x cubed minus x minus 7 by x plus 3. Now, a big piece of these synthetic division problems is you need to remember to include the zeros for the missing terms. So this goes x cubed and then x. There's a 0x squared in here, and you need that 0 in the synthetic division, like a placeholder. So it's going to be 2 and then 0 for our 0x squared, and then -1 and then -7. So you need the 0 for that placeholder. And then we need a -3. -3 is the thing we're multiplying. So the opposite of this, and so we've got x cubed, x squared, x, no x. And so now we just add down and multiply diagonally. So 2 here, 2 times 3 gives me negative 6, 2 times negative 3. Sorry. Add down, we get negative 6. Multiply, we get positive 18. Negative times negative gives it a positive number. So we get 17 times negative 3. Oh boy. 51, I think. Minus 51. So then we add these, we get negative 58. So our answer then, because we're dividing x cubed by x, we're going to start with x squared. So 2x squared minus 6x plus the 17 minus 58 divided by x plus 3. So this is not converging. It has a remainder, and so we need to include the remainder. Any questions so far? How we're doing? So if it wasn't clear, this is our answer. Now, this only really works if you've got just x plus 3. If this was x squared or something like that, this synthetic division, don't use it. You need to use the long division. But if it's x plus or minus some number, you should be good. We have a theorem. So the remainder theorem We're not going to prove this theorem. The proof is in your book. If you want to go look at it, you can go look at it. If a polynomial is divided by x minus k, so remember this could be plus, right? K could be negative and then be plus. Then the remainder is r being the remainder. The remainder is equal to f of k. Now what does that mean in like normal human terms? What this means is if you substitute in this number, whatever the remainder is what you get out of the function. The output is the same as the remainder when you divide. So if you substitute in k, if you evaluate for k, some number, it's the same as the remainder for the division. So this is my interpretation. The remainder of division is the same as evaluating the function. How is that useful? Well, that means you can use synthetic division to evaluate functions. You can use synthetic division to evaluate functions. So if we want to evaluate, I know it's a lot of writing. If you want to evaluate 5x cubed minus x squared plus 13x plus 29 when x equals negative 4, well, don't plug that in there and do negative 4 cubed. Don't do that. Instead, just do the synthetic division using negative 4 and this problem. negative 4 into 5x cubed minus 1x squared, 13x, and a 29. Now the numbers are going to get kind of large, and that's okay. But we're just going to do our normal synthetic division. We're going to add down and multiply diagonally. So 5 times negative 4 is negative 20. Add down, we get negative 21. Multiply by negative 4, and we get 80, positive 84. We add down, we get 97. 97 times negative 4. Well, 4 times 9 is 36, and 7 times 4 is 28, so negative 388. Use a calculator. And then we add down. So 360, 359. Negative 359. This is the only number that matters. The remainder is the evaluation. So in other words, f of negative 4 equals negative 359. So that's our answer. That number right there is the number we're looking for. If I plug negative 4 in for x here, I get negative 359. Okay. We have like, yes, Brian, it saves so much time. Like this problem would have taken way more steps, right? If I had substituted in, especially because we're getting like big numbers here. So we can use synthetic division to substitute. Okay. So we have 5 minutes left. I'm going to stop recording.